Hi everyone, thank you for tuning in. This is Takatoshi Shibayama, the host of the Future Design Podcast. When I first heard about 3D printing, my imagination was running wild. What if I could melt my PET bottles and reuse it to print out a new cup? What if I could melt my metal cups and print out a dish? What if I had a cool design for a toy, I can sell it on like an Etsy for people to download onto their printer? There's so many ways that this 3D printer can do for personal use and obviously industrial use. We'll touch on these use cases in this episode, but car manufacturers are printing out customized auto parts for their F1 cars, NASA is printing out shuttle parts that are resistible to extreme heat, and human organs are being printed out for transplants. It's amazing how manufacturing can be completely turned around. But it also comes with ethical considerations. Malicious people can at home print out plastic guns that won't be detected by scans, human parts that can enhance performance beyond human capabilities, not to mention the whole manufacturing industry being completely altered to even further the reduction of jobs. Like many technologies, 3D printing will revolutionize manufacturing for good, but at the same time, we have to deal with the consequences, which I believe needs to be addressed as well. For this episode, I invited Cesar Keller, the Chief Experience Officer from Alliance Systems, that helps B2B companies and startups bring meaningful innovations, technologies, services, and products to life. So without further ado, here is Cesar Keller. Thank you for being on Future Design Podcast.
Awesome. Thank you for having me.
Great. And this is a very interesting topic for me. I say this quite a lot in my podcast, but it is an interesting topic. 3D printing and additive manufacturing has always been something that I've been thinking about because this is a new way to customize and personalize manufacturing. And I think that in many cases, we are accustomed to buying products that are already mass manufactured, whereas in the future with 3D printing, a lot of things can be personalized for us, or we can personalize it ourselves to make products that we really want. So let me open up the conversation by first asking you this question. Who is Cesar Keller?
Well, that's a very interesting one. The best way to describe a little bit about myself, besides just title and company, is I've just been one of those guys that I've always been an analytical thinker, and I've been a designer and a creative. And I have a good balance between, sequence and thinking and concepts, but also being creative. So when it comes to technology and when it comes to melding technology with business and being creative, it's just I've always had a passion, but I've always been into either designing, building, creating, but always trying to leverage it from a business perspective. Other than that, I'm a father of three. I'm a very curious person. I love to optimize things. So hopefully that just kind of gives you a little bit of insights into my character and kind of what I love doing.
Yeah. And how did you become very creative? I mean, there's always something that probably is innate in you that kind of builds up that creativity inside of you. Where can you kind of go back in history and find yourself being that creative person?
As far back as I can remember, and my family tells me whether it was crayons, markers, just drawing. I know my dad was into like doing a lot of sketches, and I saw him sketching when I was little. And there was just something about grabbing a pencil or grabbing some colors and just putting something on the page. I could get lost in it. And my parents would tell me like I used to do that a lot for many, many hours. So there was some kind of focus. And then it just kind of turned into lots of classes, lots of art, lots of painting. So I was doing all kinds of stuff. My parents supported that as I was growing up. And then it kind of took a little turn when computers came out. I was like 10 or 11. We got a Commodore 64, I think it was. And I couldn't stop staring at the screen and going, what is that? And how can I do something with that? So that's when the creative kind of took a turn into technology a little bit. But yeah, just been doodling since I was a little kid.
Right. And I'm sure that as a parent, you want to keep nurturing that for your kids. And, that's what I think about myself personally, even when I see my kids doodling around or, thinking about creative ways to play. And I really want to continue fostering that, especially in the future when, a lot of the work can be focused more on creativity. I think it's an essential part of people, kids, whoever they are, to keep nurturing that part of themselves. Now, you are working as a Chief Experience Officer at Align Systems. So could you tell me a little bit what Chief Experience Officer actually means? Because I never heard of that before.
Sure. Really, it's ultimately a combination between customer experience, which is labeled as CX, and there's a lot of user experiences that you create as we develop products. But ultimately, it's just making sure that all the products that we're developing are not just system oriented, meaning users use systems, make sure they have a great experience inside of that system, but it's more of from system to system. So whether it's a website, whether it's social media, whether it's a mobile application, whether it's customers arriving at your location in a physical sense, is tying every single experience and touch point to make sure you're maximizing the satisfaction levels across the board. So just bringing some of that discipline into how we develop products, how we treat our customers, and what the end goal is to make them as successful as possible.
Interesting. And now we're on the topic of 3D printing. Now, how has Align Systems been in adapting this 3D printing?
It hasn't. In fact, I know that we were connected, through a mutual friend, and we were just discussing really cool stuff. The best connection I can give you is I took an online course and I got a certification where I did design thinking. And this program was pretty intense as far as what you learn. And one of the things they talked about is rapid prototyping. As someone that's helping our teams build products more on the digital side, we still had to cover what it's like to build products from a physical perspective. And I learned a ton about additive manufacturing, all the technologies that come with it, and how it helps businesses prototype whenever you want to do rapid prototyping, save a lot of money, reduce risk. So a lot of that kind of knowledge and technology, just came through that course. So when we were talking about how does that affect the future, what would be a good topic to talk with you, that's one of the options we threw out.
Interesting. And I think that 3D printing right now, still generally, even if you go through Amazon, I mean, there are cheaper ones that you can purchase by yourself, but still, I think it's in the industrial sector that it's making a huge impact, not on a personal level. Where do you see a lot of the 3D printing that is being used across industries?
You know what? I guess I'll start easily, right? A lot in the hobby side before we get into the professional side. There's a lot of hobbies where, because like you said, anyone can buy a 3D printer that's now available and pretty resourceful as far as price is concerned. There's a lot of little hobbies that I see picking around. There's one hobby that I participate in a lot. It's RC racing. And these are like, 10th or 1/8 model cars. But all the race geometry that you can think about that you can change on a large vehicle, you can actually change. In fact, I have one right here just to kind of show the screen. And you can open the car. And it basically just has all the components that you would have, but you can see springs, you can see towers, all these little parts. There's a lot of hobbyists that are like, you know what? We're going to custom make little parts for this thing to make it go faster. But if you take that and you scale out, I did a little bit of research, and a lot of the F1 Formula teams, they use 3D printing all the time to test models, to test wings, aero packages. They're actually using some of the firmest and most moldable and flexible kind of resin and plastics and carbon fiber. So they're really to the next level. But rather than building something that's robust, they do a lot of 3D printing to test, to be able to make sure what goes on the car. So from hobby all the way to professional level, that's just a cool example of from toy cars all the way to Formula One. Some of the case studies that I reviewed, space engineering, obviously there's a ton that's being used there. One of the cool projects that I saw was they were building the bottom of the rocket with 3D printing, because one of the biggest problems with rockets is the stress points whenever you have to weld something together. There's a lot of stress. But if you do 3D printing with the right kind of materials, there's no weaknesses, so those parts can last a lot longer. Another cool case study that I read about was the environment. They were using 3D printing inside of the ecosystem for barrier reefs, and using that to kind of grow these reef and ecosystems in the ocean, which are, have a lot of havoc and a lot of negative stuff going on there. And they found out that, hey, just by doing some 3D printing and introducing certain pieces of those 3D prints, that coral could start growing in a healthy environment. And then some of the coolest technology that I've gotten involved in, because I have some connections and some family that work in the medical industry, is getting into bioprinting, where they're starting to print organs and help patients, whether it's prosthetics, and then hopefully in the future all the way to like complex organ printing. So there's a wide variety out there, and it's just a really intriguing topic of how complex this technology can take.
Yes, in the beginning you were just showing us the model car, and how you can build small little pieces so that you can make those wheels turn faster or make it lighter. I think that's really interesting because from all the parts that you can actually buy in a store to make your car faster, I mean, a lot of the times, as I said in the beginning, you have to buy something that's already mass produced, and maybe sometimes it doesn't work for you, or your competitor could buy something very similar to yours, and it doesn't really improve the speed that you're trying to get. So why do you think that a lot of these things that are being created right now can be put away from like these industrialized manufacturing into customizing by yourself? And how does that for me, like when I think about it, it's like, there's a lot of people who are working in the industrial manufacturing industry, and if you can actually start doing it yourself, to me it feels like there's a lot of jobs that potentially can be replaced, or the whole industry can actually shrink, so because you can do it yourself. I mean, how do you see that transformation happening?
Well, two things is it leads to innovation for sure. And healthy innovation and competition spurs, a lot of great thoughts and a lot of advancements, right? So like you're saying, I have something very, very specific and custom that I have in mind, whether it fits my body, whether it fits a vehicle or a hobby or a toy or a musical instrument. These are very personalized, specific things that I want to take this challenge on, and I want to improve something. So when that power of building something gets down to the individual, I think it obviously empowers people to make change, and then it pushes innovation further. So that's one of the aspects that I really like about this. And on top of that, the technologies are just getting better and better, and cheaper and cheaper. So depending on the application, of course, you can do some things that really make a difference, which is pretty neat.
Yeah, I think so too. And I was thinking about some kind of ideas where designers can design something that could be used for 3D printing, and then uploading that onto like an Etsy kind of e-commerce site where people can buy a particular design and they can download it onto their 3D printer. And then, there you go. You get your personalized or customized design that you probably won't get in the kind of regular market. And I think that creates a whole new industry of designers that they can think about so many different type of things. And even as a hobbyist like yourself, when you want to make model cars and you think of an idea, maybe I can make this part out of carbon and make it lighter or something, then if you have an idea and you have a design, then you can potentially monetize that as well.
That is correct. I have some friends in the space that have been a part of the RC community for a long, long time. They actually started a business. They got a CNC machine. They got some other 3D printing stuff. They print towers. They print some, off-the-shelf parts that you can't get anywhere. They're very specialized. And obviously they sell them because it changes the performance of your vehicle, or it might be a cool gadget that makes it look cool. So it's both for cool or for performance or for both. But you're totally right. It's almost like these little micro markets are starting to appear, whether you're selling the stuff online or you're starting a little business. But you think about the scalability, right? It doesn't just have to be for the hobbyist world. Depending on how far you're willing to take it, it can start making a big difference in regular manufacturing, which is pretty neat.
Because Because I think the whole part about the industrial manufacturing part is that that company or those companies have to build it them and then sell it to their customers. But it can make the company extremely asset light if you can delegate all that manufacturing to a 3D printer that the customer has, and all you are doing is selling a design, and you're just keep on innovating that design so that you as a manufacturer are more of the specialist in thinking about a design rather than doing the actual manufacturing itself.
Absolutely. I'll tell you a cool story that I learned through that design thinking program. They're coming out with smarter and smarter software, not just generic CAD software. One of the examples that they put out was there was a team, they were in the shoe design business. And they were basically posing the question of, imagine what it takes from an engineer and design perspective to design a woman's shoe, specifically like with a high heel, for example, right? And if you're a shoe designer and you just start breaking simple concepts up, there's only so high that a heel can be before the shoe is not comfortable anymore. And based on the height, there might need to be a structural integrity as to how thick the heel needs to be so it doesn't break. And then you start getting into all these little mathematical formulas of depending on the stability, depending on the size of the shoe, and depending on the height of the heel. These are the constraints or the tolerance that would be great to design a good shoe. Now imagine if you took the software and you're an engineer / designer for shoes, and you are a professional that understands all those ratios. You could essentially create software that is smart to say, here are the correct models, here are the correct tolerances, and here are the right margins, so that you might not need to be an engineer or a full designer, but you can almost be like a semi-engineer or designer and use this software, and you can allow the software to tell you, here's all the permutations of a shoe that's gonna be just right. So imagine what you can do with that software. It's not just about custom design from the beginning, but if you have the right either machine learning, artificial intelligence, or tolerance levels, the software itself can help you design much faster because you're not going to design things outside of a wrong tolerance. Now that's just the model of a shoe, but imagine how that can apply to anything that you're designing. So I think it's not just the evolution on the hardware side or the materials that you're doing with 3D printing, but it's also on the software side and how smart that design is to help you design personalized things for any given industry.
Wow, that's really remarkable. And you were talking about the use cases in the medical side as well. Obviously, organs, you were talking about organs, and maybe in the future 10, 15 years that people can be able to 3D print particular organs in your body to be replaced. I think organs are very personal things as well, highly personal. Lung is not just a lung, your heart is not just a heart, it's specific to your body, your weight, your genes basically. So having that software to be able to analyze what kind of material, I wouldn't say material, but like how that particular lung should really fit into your body is something that's really important. And then I think that new businesses can be created to be creating these softwares to understand what kind of particular organ that you really need to print out.
Right. If you take a look at, let's say today, some of the best use cases that I've researched are prosthetics. So imagine people that are missing limbs or they just had an accident. Obviously, we think about a lot of our soldiers that go to war, come back, and they're missing limbs, right? Well, these prosthetics not only are bioengineered to fit exactly their bodies, but they're starting to combine a lot of that with robotics or sensors or things where these are moving parts that can help them with those limbs. You think about, there's technologies where they've reproduced ears and noses, so parts of tissues and whatnot. And there's been a lot of advancements when you talk about the esophagus or the trachea. The personalization, everyone's body is different. The way that you can create stents to open up vessels or pathways, and the way that you can mold around the esophagus and the trachea to really help out either places that are deteriorating or damaged tissue. That's where this very highly personalized design starts matching up with the medical science to be able to help people with their body. Today, the lungs, my father was a part of the Mayo Clinic lung transplant program. So I've had a lot of great conversations with him about, what is it going to take to have these very complex organs in the future? Is it even possible? And what kind of ethical restrictions are we dealing with today versus the future? They've actually done tests at the mice level where they took lungs from a mouse and they were able to do 3D printing with bioprinting, and they were able to do the complex organ, at least at that small size. So theoretically, more complex organs will be able to be bioprinted in the future, maybe 10, 15, 20 years out. That's definitely going to be possible. So it's amazing how we're going from even simple things right now, but it can just get more and more complicated as the technology gets better, for sure.
Yeah. Because right now we're basically, if we want to have a transplant of our organs, we have to wait for somebody to pass away, and then hopefully we can be on that list and then be on top of that list to get our organs transplanted. And many people, I assume, that pass away because they don't get that transplant in time. So that completely alleviates all those problems of that, and be able to on time be able to create your own organs. And you touched upon a little bit on the ethical side of things. I think sometimes that people can try to generate certain tissues or certain muscles or whatever they are to enhance themselves. And then this is something that I kind of worry about too, is like, because now like the boundaries of what we can do to our bodies have been pushed, right? I mean, we have godly bodies that were meant to be what they are, and now we're advancements of medical. We are being able to push those boundaries so that we can almost become God, and then we could start creating certain body parts that are enhanced just so that we can run faster or jump higher. It does create a ethical problem going into the future.
Yeah, I mean, if you take the basics of today, right, just like you said, there's so many people that pass away because they can't get the organs in time. And obviously, it takes a tragic death, to be able to receive these particular, organs. So right now, if we just use the lung example, right, those are very delicate and precious organs. So whenever, those lungs are available, they deteriorate so fast, and they have to be put into very, very special systems and get into someone's body very quickly. So the ethical challenges that I've spoken with my father are all about, we do not want to waste that precious gift of life, right? So ethical considerations that you think of today are, did this person sabotage their health because potentially they were smokers, and by smoking, they damaged their own lungs? There's consideration for age. Obviously you want to give these precious organs to people that are going to be able to survive, because it's a pretty intense surgery, right? So once you get to a certain age, how do you tell someone no because they might be too old, and their chances and the marginalization of survival go down based on age, and many other factors, right? If you start thinking about bioprinting, though, in the future, let's say hypothetically, you now can create these, well, then the supply-demand curve is totally going to change, right? It's okay, we have plenty of organs because we can just make them. But at what point, just because you have the technology, do you actually implement it? And now you start thinking about who's going to pay for it. Is it going to be insurances? Is it going to be you? Is it going to be a combination? Is this going to be something where only rich people can live longer because they can afford if the insurance or whatever? So it's not just about the supply and demand. The other considerations I talked about with my dad were, there may be a need to do biogenetic engineering so that these transplants are possible because these are not real organs, right? So as you start thinking about the complexity of all these organs, today they're dealing with real organs, and they have to go through a special process where they decellularize and then they recellularize, and with stem cells and scaffolds, it alleviates rejection, right? But in the future, if you have to have gene sequencing and you talk about CRISPR and you talk about the RNA and these proteins that can change the biology in your DNA, well, that's a whole other thing of now these ethical considerations have to be at play. Are you going to be changing the chromosomes? Are you going to change your DNA just to have these parts? Or can we do it without that need? It's just things can change quickly, right? And then there's what you talked about. Eventually, we might have some biomechanical people out there with all these parts and organs and whatnot. And the technology might be that they can breathe better and they can see further and they can be stronger. How do we deal with that? And, is it just people that can afford it, or is it something that everyone can have? So it's crazy how awesome the technology is going to be, but it just begs the question, right? How far do you push? And what do you do? And when are you starting to play like you're God, right? And there's obviously people on either side of that debate, but it's a fascinating debate.
Yeah, I mean, I think we already opened the Pandora's box on that. And, when I always think about these issues is that when you open a Pandora's box, you're always thinking something positive. We can change the world. We can make people healthier. But at the same time, there's all these negativity that also comes with it, which we don't consider a lot before we even open that box. Now you talk about, bioengineered people, but also when you think about, being able to try to live longer, we are generally put into this place to live a certain amount of time. Maybe some people might disagree with that. Maybe it's a malfunction of ourselves that we can't live forever. I've heard insane debates around that. But at the same time, I think I was, reading something and I was debating with myself, if we can live much longer and we can replace our organs or body parts with another very quickly, regardless of the cost and, putting those things aside, how much are we going to value each other? Because if we can live longer and if you could just replace anything that you want so that you can continue living, then are we going to really value life? Right? Because if you could live forever, this is like a whole different ethical question, but if you can live forever, then are you going to be able to respect the person, not to hurt the person? Because, they could just patch them up very quickly. Then, what does that mean for us to be like immortal humans?
And you can also think about, what do you give back, right? If you can live forever, are you just going to drain and take away from society? Or are you going to give back to humanity? And what are you going to give? What's going to be your legacy, right? I almost equate it to hacking, right? We're in the industry of building software and, kind of we know how technology works. And the question is always, can you design and build something that's hack proof? And the answer is no, because inherently it's all about the intention of how you use technology. If you are going to use and build and design amazing technology, but you want to use it for good, then you're on the white side, right? You're the white hat. But if you know the technology, you know exactly how it works, you can have bad intentions and you can use it for evil. So if you take just that concept and apply it to what we're talking about here, are you going to use this technology to keep people alive and use it for good? Or are you going to use this for evil? And are you going to manipulate situations? Some of the documentation that I've read about, some of the there's series out there, documentaries where you can look at, and they pose really amazing questions. Like, okay, we know that there's a gene that we can make it to where you only need 4 hours of sleep. We can change this gene and all of a sudden you have no pain. Well, we can change these genes and all of a sudden the chances of you having higher IQ are possible, so you can be smarter. We can change the DNA for your muscle structure so you can be more of an athlete, be taller, bigger, stronger. What have I just described? You can essentially bioengineer a soldier, right? And totally. So now you're talking about applying this not for medical purposes per se, but you're engineering humans to take specific tasks. And that's kind of scary, right? So it's all about how you leverage the technology and what you do with it. Other considerations that I've thought about are, okay, so now we have this whole engineering of genes and DNA. how far do you take that to the point where it's going to be passed on forever and ever and ever, because it might have been applied to your genes that get passed on to your children and their children's children. But now you can't go back. You can't back and change that because you've changed the DNA. So there's a huge debate on, do you just do it at the level for your body, just for you? And like, it's almost like stay away from sperm, stay away from ovaries, because the second you make those changes down to the germline, it can be passed on forever, and we don't know what we're doing. There can be consequences down the road. So it's just this whole ethical debate of who controls that, what countries are going to not do that, what countries are. So there's a lot of responsibility that comes with all this cool technology, and I hope that it's used for good. You know, that's the best way to say it.
Yeah, it kind of reminds me of this classical music, a movie called Gattaca, where everybody has the perfect genes and they're the perfect people, but then there's this one person that has a faulty gene and has a certain problem, and you know, he gets kind of pushed away in society where he can't actually live amongst other people. And you know, it really begs that ethical question: is do we need to be that perfect all the time? I mean, we always accept people for their imperfection, and I think that's the beauty about how we are. We're not supposed to be perfect. But anyway, I mean, I think we could talk about this quite a lot. But going back to the 3D printing side of things, but also talking about ethics, I've seen people create guns out of 3D printing as well. And I think that's just the tip of the iceberg. I mean, I think we could make so many different weapons out of it. We ourselves can become weapons as well. I mean, you know, it does kind of make me a little bit concerned about this whole 3D printing at the same time, because it opens up a huge concern about people being able to, you know, create whatever the weapons they want to and be armed at all times, even though the government might say you can't have this or not. I mean, who's going to look at everybody's houses, right?
That's right. And obviously the detection systems right now, a lot for anytime you go into schools or airports or you name it, right? These detection systems are obviously looking for metals. But when you start talking about, you know, plastics and molds and resins that have, you know, all the right construction qualities to be able to fire a ballistic bullet, I mean, it's kind of crazy what is being done, right? Yeah, it's again, with technology, it's, are you going to use it for good? Are you going to use it for evil? The do-it-yourself mentality is good as long as it comes with responsibility. Yeah, a lot to think about for sure.
Yeah, I always wonder, because ethics is generally taken out of education, and you know, before maybe we had religion for us to kind of think about and be ethical, but now that a lot of, you know, societies are becoming atheist or not really concerned about religion, the whole idea around ethics is completely taken away, and you know, money probably replace that. You know, if you can make money, it doesn't really matter how you go about things, as long as, you know, your money and everybody thinks you're successful, then it's okay. And you know, that kind of really concerns me quite a lot, and this is kind of the overarching theme about my podcast, is how do we bring back ethics into building businesses and technology. But you know, let's kind of move on a little bit. And you know, you were talking about these guns and things that are made out of resin and plastic. I mean, they're very durable. And you know, and you were talking about rocket ships, the bottom of the rocket ships being made by these materials that can withstand that much heat compared to whatever they had before. Maybe because they're not welded correctly, or you know, maybe because of the joints, it makes them fragile. I've seen bridges and houses also being made out of 3D printing. I mean, this durability is extremely fascinating. I mean, how do they come about building such resistance in the materials, or the way that 3D printing is creating these things?
Sure. So maybe we can talk a little bit about the variances, right? A lot of people that have talked about or seen 3D printing, it's mostly like the amateur or stuff that you can buy for your house, right? Which is typically just, you know, baseline plastics. But there's a lot of different styles. So number one, there's what's called SLA. They can use layers, and they basically burn layer upon layer, and it's like a photopolymer resin, which is a higher quality resin There's also FDM, which is basically thermoplastics. So these are just like polymers that basically change based on liquid state and the application of heat, and then it solidifies when it's cooled down. There's MJM, which is like multi-jet modeling. So here you can just add multiple layers of thermopolymers, and these things can much better than resin. Now you start talking about, okay, now there's multiple types of engineering that we can do as we apply these different types of materials. And then obviously all the way to bioprinting, which is more like tissue, right? But yeah, the technology is getting so good that, at the professional level, they can actually start printing parts that have no joins, they have no welds, it's just one solid piece. And when you start thinking about products being built that way, now you're talking about longer, sustainable pieces that won't break, or there's just less stress points. So it is kind of cool and crazy how it's just, way more than just simple plastic, right? There's different grades and different durability.
And also, do you think there will be a time when we can take, let's say, a cup or a PET bottle or something and melt it down ourselves, and then place it into a 3D printer and create something ourselves? Because I'm thinking about in terms of reusing, recycling, and of course, a lot of the plastics that we have can be recycled, but majority of them you can't really recycle them because they have a certain color, or maybe the durability already is kind of worn down, that even if you melt it, it wouldn't have the same characteristics as before. But I find this personal use of 3D printing can be very ecological at the same time.
I think that's actually a huge topic, through a lot of manufacturers that are developing product. They're always thinking about, okay, if we build this chair and we break this chair down because of its old age, what parts of the chair could be put back into a recycling process to some degree, so that we can re-engineer another part or even redo the chair, right? So it's just kind of into the equation of reusability. And as all these particular materials and the manufacturing process gets better and better and better, I can see a future where there's a lot of companies that are super responsible and like, you know what? Every single decision that we make to build this product is based on eventually breaking down all these parts and recycling them to recreate other things. And I know, 3D printing is just one part of the manufacturing process, but there's a lot of companies out there that are starting to think from an ecological perspective to just not be wasteful. And that's an awesome opportunity. I haven't studied too much about what resins can be broken down and melted and kind of reused, but I'm sure that there's a lot of people trying to figure that out because, again, it's all about eliminating waste wherever possible.
Yeah, I think it might be great for corporate responsibility to think about how can we manufacture or create certain materials so that they can be reused again. As I said, plastics, a lot of them actually are not recyclable because of that. And if they can create plastics that can be reused over and over again, that is actual innovation, right? And for companies like Coca-Cola or something that are making these bottles and saying, look, we're creating plastics and that can be dissolved over time, but at least you can reuse it over and over again for your own personal use. So it doesn't just go straight to the bin, but you can create it so you can make another cup out of it. You can make another chair out of it if you have enough material. I mean, this is a great way for showing that there's responsibility on the corporate side, that they're taking action.
I agree. I mean, just kind of like you start dreaming a little bit, right? You can almost consider, how we have trash compactors and they just take your trash and they compact. There might be in the future, it's like, okay, throw all these types of materials and these things into this machine and it'll start to compress all those particular materials. It can melt them down and out comes whatever. And those are the things that you use to put into your 3D printer so you can make stuff out of stuff that you are disposing. I don't think it's too crazy to think that kind of technology and that kind of reprocessing is definitely possible. And I'm pretty sure that we might see that in our lifetime. But 3D printing is still kind of at an early age, so there's a lot that can be done with the tech.
Yeah, for sure. And that's kind of what I'm really looking forward to is that because we have so much material in our house and, obviously a lot of people get just bored of having that thing and then they just throw it into the bin. I mean, those things can be reused over and over again if it was created by the right material and there's a process where you can actually, change the usage of that. And I think that's kind of the way forward in my view. And I think that, companies that are building these 3D printers or materials can start thinking about ways that they can use this for good as well.
You
Are
start
there
watching
other
a lot of the sci-fi movies, the whole let's go to Mars or let's go to other planets. I mean, if you're going to have expeditions like that, you're going to have some really smart engineers because, you can't just throw things into space. There's a lot of weight to power ratio that they got to figure out. So they're going to have these machines are basically the machines that are going to make a whole bunch of tools and they're going to make a whole bunch of products. So I'm sure there's really, really smart engineers at NASA and SpaceX, and they're thinking about all this stuff and how it can apply to the human race when you get out into space. And hopefully some of those technologies will just trickle down to everyday use. But that's an excellent use case as to let's get it going. Let's be as smart as we can be, and what can we build and take to Mars. So there's a lot of cool stuff out there that maybe it's science fiction to some degree, but if you've seen it in a movie, someone's probably trying to figure it out at the same time. So
I think a lot of our imagination comes from sci-fi movies as well, and as we think about interesting ways of even innovating certain things, then it actually becomes reality. I remember watching Back to the Future when I was a kid, and I think there were like comparisons showing that in 2000, what was it, 10 or 15? Sorry, I forgot the particular day, but if you compare 2015 and Back to the Future and compare it to what reality is now, there were actually some similarities of what they made or what they imagined in that movie actually coming true. And you talked about the space junk as well. I mean, I have a friend that works in a company that's trying to remove space junk, and they're sending these mini robots into space and collecting all these little junks out there, and then just pulling them down into the atmosphere that they just disintegrate. But if we're going into Mars and going into different planets, we can't be just leaving behind so much waste because that planet is not ours. Even though you might think that there's nobody there, but it's a responsibility to be able to take them back or at least reuse them for something else and not just leaving them behind. Can you do you think that there are other innovative ways that we can use 3D printing that we haven't touched upon yet?
Well, the main use cases that I've seen are obviously research and development, right? Just typical R&D. Obviously, production parts we've talked about, whether it's at the hobby level, at the professional level. There's a lot of repair and maintenance things. You talk about almost like companies that think about planned obsolescence, right? Before it's like they made a light bulb that can last whatever, 100 years, but obviously now light bulbs only last so long. So what are these little parts and pieces that if you are doing it yourself and you're repairing, what kind of maintenance can you do on X things that you're building? And then another great use case is kind of like little jigs, fixtures, and just little tools, because you can basically design and customize anything you want. Those are the huge use cases for a lot of 3D printing now. And then obviously, depending on what science field you get into, it obviously can get more complicated than that. What I've read a lot is that even though 3D printing can provide a lot of solutions, getting into 3D printing at the professional level, it can help you save a lot of money in R&D and prototyping, but there's a huge learning curve because you have to learn how to adapt and customize it for your particular use case scenario. And that takes studying like what are the best materials. What is out of all those things that we talked about, there's different ways to do 3D printing or additive manufacturing. What is the best use case for our particular context? So it's still, I think, in its infancy, but I think in the next 5-10 years, it's going to definitely change the game for people that are developing, physical product.
Interesting. Yeah, I especially like that part where you talked about how are there actual malfunctions in a product that they can't last forever? I mean, I think a lot of the industries now are thinking about product life cycles of like, let's say 5 to 10 years so that they can resell it. Just like, our iPhones. I mean, they're not made so that they can keep upgrading the OS. So they make sure that you have to rebuy them after 2 years. I mean, I think that's already a flaw. Well, for the business model itself, if you want to make money, that's great. But for the product itself, it's such a waste because you can't use it, even though it's a perfect machine. And if you think about our regular daily things like refrigerators, I mean, there are things that can last so much longer. In the past, there were like fans or microwaves or what have you that actually can last much longer than the products that we have now. So I think that manufacturing industry decided, oh, I want to make more money, so I'm just going to dumb the product down so that they don't last longer. But if we can actually repair parts ourselves to make it last longer, rather than having to buy the whole thing all over again and make those products useless, I think that's a really great way so that we can stop consuming so much and keep our materials to last longer.
From a customer experience perspective, I can see in the future where you mentioned refrigerator, or it can be a dishwasher, or whatever the case may be, right? Imagine a company that really cares about their brand and their loyalty and their stuff lasting for a long time. I can see them not only selling the product, but they can sell almost like a subscription. And they can say, listen, if you have this 3D printer, here's our catalog. And you can literally, as a part of buying that plus the subscription, you can download whatever design part printed in your house and then replace those parts right there in your house so that machine can continue working. It's a pretty abstract thought right now because we're like, okay, we have to, the manufacturer, the company that created this stuff is what has to have all the inventory of all the parts. But imagine if all the parts were virtual as a part of a marketplace. So when you buy X thing from X company, they can say, as long as you have a subscription to our marketplace, come and download, and here's all the parts that you can actually replace yourself as a part of our support package. I think these kinds of things are going to be coming out in the future, and it's going to change the way we think about customer service and support to some degree. It's just a matter of time.
Yeah, I actually think that's a really good business model. As a value investor, I used to look at different business models and what actually are cash generative businesses. And I found that companies that actually make, let's say, for an example, an elevator company. So basically, they don't really make money on the elevator itself when they sell it. They actually sell the maintenance. And that creates recurring income for their business so that you can see a long projection of the maintenance fees coming in so that you can make up even with the small loss that you make on the elevator and plus some more. Or like, let's say Nescafe, you have the coffee machines. Basically, they don't really make that much money on the machine itself. They sell you those pods. And then the longer you use those pods, the more money you can make. So it's all about creating these recurring income models for your business so that you don't have to rely on one product that you sell and you want to make the most money out of it.
That is correct. I mean, in the software world, that's been proven time and time again. Traditionally, if you look at the past, you would buy software in a box. It would come in discs or CDs or DVDs, whatever it was, and you'd kind of upload, and you'd have to have some kind of code that protects you from stealing or pirating the software. And what would happen is if I'm thinking of Adobe since I'm a designer and I've used their products forever. I just remember, okay, every year they're coming out with a new version, but I have an agency with 10 people that are using this software. I might skip a version to just save a little bit of money. Do I really need the latest features? Well, that didn't really work out. Imagine all the money that Adobe was spending to protect people from pirating their software. Like, think about all the money spent on those codes and making sure that, those codes weren't being stolen. And then the distribution of the boxes and the creation of the DVDs and CDs that's a ton of money. Now it's just, okay, here's Creative Cloud. It's $49 a month, and you naturally get all the updates that we have, but you're paying us on a subscription from month to month to month to month. So it was better for the consumer because it doesn't cost a ton to buy the brand new software, and we're getting every single update as we go along. Now think about how that can change if 3D printing turns into the model like I spoke of, right? Now here's your product, but if anything fails on your product and you need these parts, and we know that these are the parts you're going to need, just download them and print them yourself and just pay us a little subscription so you can download these parts at any time. It's a very similar model, but it starts to feel more like the Jetsons, right? It's like I have this little oven that I can bake products in. It's just kind of mind blowing.
Yeah, for sure. And I think that even now, I was just thinking about, the Tesla cars as well. A lot of people are saying, well, putting a high value on the business because they're thinking it's a software business rather than a car itself, because you can keep upgrading the software inside the car so that it becomes more of a recurring revenue type of model, where even if after you sell the car, there's so many software updates that you have to do so that you can continue making money from your customers, and then keep them very satisfied because they can still run the car but have all the necessary software in there so that it's always up to date. And I think that that software mentality going into the manufacturing side of things is a great way that people can stop wasting things, and then continue being happy with the product that they actually purchased. Yeah.
Exactly.
Yeah. Well, I had a really awesome conversation, and I can think of so many different ways that 3D printing can make our world better. Are there any parting messages that you would like to say, and then I guess we can wrap this up?
Well, number one, awesome conversation. Takatoshi, thank you so much for the opportunity. I've spent a lot of time reviewing this just as a technologist. I love technology and solving problems and learning. And the more I got into it and preparing for this conversation, a lot of cool stuff came out. And I think we did touch upon what could be in the future for us, and how we can change our lives for the good, and being careful about the negative considerations as well. So thank you very much for the time, and appreciate it.
Thank you so much, and I hope to talk to you again about different technologies.
Awesome. Yeah, let's do it again. We'll pick another great topic.
Hi, this is your host Takatoshi Shibayama. Thank you for listening all the way to the end. Now, if you enjoyed or disliked the show, please let me know by writing in the comment section. The only way I can improve or add value to you is through your voices. If there are any topics that you would like me to pick up, please also let me know in the comments. I'd love to start chatting with you all. And if you would like to continue watching the show, please subscribe. Thank you.